Hello, civil engineers. Welcome back to the lecture. So, in this lecture, we'll take all other columns and we'll try to do. So now what I've done, instead of going to this Excel sheet and checking all these things, I've taken a screenshot of this and I've pasted it here, and directly from here we'll see that. Okay, the C1 column is done. Next is C8, C12, and C25 column on F2 footing. So next is C8, 12, and 25. See, directly you cannot take all the column from here. Remember now. Now you understood how to prepare the BBS. Now try to understand the concept now. C8, C12, C25 is one group where we say that these three columns are resting on F2 footing. But again, when you do the bar bending schedule, you need to check whether C8, 12, and 25 column has the same size and has the same reinforcement. So for that, again, you have to go back to the drawing. Okay. So when you go back to the drawing, what is the name of my column? C8, C12, and 25, right? So C8 is here, C12 is here, and C25 is here. Fine. So both the column size is same, 200 by 350, 200 by 350. Good. Look at that diameter of the bar, 16 diameter bar of 8 number, 16 diameter bar of 8 number. That is also correct. Look at the spacing. This also should be same. 8 diameter at 200, 200. And also the lateral ties also should be same. Here also you have one big ring and one link. Big ring and one link. That means everything is same. If everything is same, then I can put that under the same, what is that, same group, and I can say that C8, C12, C25 column on F2 footing. Okay, and I'll write 3 number. Now you may ask me, so what is the difference in this? So for that, I'll show you one more example. For that, you refer this example. Yeah, okay, go for this. Check out here. Now what is written? Come to the third one. C9, C10, 11, and 20. I'll write here. Okay, what I have to write? C9. Okay, this is grouping what we did initially. Okay, C9, C10, then C11 and C20. So these are the column which are resting on which footing? Which are resting on F3 footing. Good. Now I need to check whether C9, C10, 11, 12, C20, this column has same size or not. If it is same size, it's okay. Whether the reinforcement, whether it is having the longitudinal reinforcement, all the diameter and number of bar is same. That also I need to check. And also I need to check the lateral ties and the spacing and the diameter is same or not. If everything is same for all the 4 columns, only then I can categorize this as one group and do the BBS. Now here you see the difference. Okay, you remember the column now, written it here, C9. Where is C9? Where is my C9? C9. I need to check C9. So where is C9 now? Okay, C9 is not visible anywhere. Yeah, it's here. See, C9, good. C10, good. And C11. So C11 is here. Okay, fine. C9, C10. You're able to understand, no? C9, C10, and C11. And C20. So where is 20? 20 is here. Okay. So 20 is here. Just concentrate on this much part. I'll keep it here. Yeah. Now you can get an idea. If you want, I'll circle it. Okay. So it is C9 and 10. So C9 and 10. Okay. Then again C11, C11, and C20. Good. Now you check whether everything is same. C9, C10. It's a 200 by 350. Good. C11, it is also 200 by 350. C20, it is 200 by 200. So that means even though in the estimation my column were resting on F3 footing, in my bar bending schedule, I cannot take C20 in this group because 200 by 350, 200 by 350. Whereas my C20 column size itself is different. If my column size itself is different, then obviously the cutting length of the lateral ties will be different. So that is why I need to put this in another category. Got it? Other than that, look at the diameter. C9, C10, it is a 16 diameter 8 bar. Good. C11, 16 diameter 8 bar. That is also okay. But again, come to the C20, it is 16 diameter. That is okay. But number of bar is only 6. Whereas here we have 8 and 8. That means I cannot say C20 column belong to this group. So nothing will happen. You have to make a separate Excel sheet for that. That's it. Instead of writing 1, 2, 3, 4 numbers, you have to write 3 number, and C20 you have to do separately. That is what I wanted to tell. Got it? No. Whereas in the previous case, okay, whereas here C8, C12, 25 was lying in the same group because The dimension, the column reinforcement, everything was same. But here the case is not that. Okay. So that is why when I done the Excel sheet, no, you see here, I've shown that. I've written C9, I've written C10, I've written C11. So since there are three number, I've written three. Whereas C20, I've taken separately. See, C20 column and F3 footing. Got it? This you have to understand. Okay, fine. Anyhow, that was the main catch in this lecture. I hope you have understood. Okay, so if you find it so difficult, then you can even do it individually, like I mentioned. You take all the column individually, but again, your calculation will be very lengthy. You take C27 separately, C28 separately, C25 separately. The calculation will go lengthy. So that is why take this as a base, take these things as a base, these things as a base, and then you find whether all the column are falling in the same category. If not, you just separate out from there, and then you make another row for that. It's very simple. Okay, fine. So with this understanding, we'll go and we'll finish it off. Okay, this was done. I'll go to the C8 column. So C8, C12, C25 will come. F2 footing. So C1, this column size I've written here 200 by 350. F2 footing I've written the size, and depth I've written here, and F2 footing diameter I've written. For where you find all these things, you go back to the drawing, structural drawing. F2 footing come here. F2 footing is 1400 by 1400 by 400, and 10 dia 150, 10 dia 150. So diameter I require 10 and 10. Same thing I've done the input here. Okay, 10 and 10, 1400, 1400, 400. Right. So accordingly, what will happen? This and this will remain same. Okay. Only this also, this also, same formula you have to apply, because what you do, you just copy from here everything and you have to paste it. This no? If not, I'll teach you once again. Another thing, you have to copy it in this way. Like this, you have to copy. Okay. So once you copy, Control C and come to the Excel sheet. Where was it? Yeah. Come to the Excel sheet and say Control V. Okay. Then you drag all these things in this way. Everything will be fine. You delete this. Okay. Drag it in this way. Okay. I mean, here it won't work out. Let me put here, or I'll do one more Excel sheet. Yeah, fine. See here. Now it is correct. No, this is how it looks. Now small changes you make 1400, no 400, no. Accordingly, you make all the changes here. That you can do. No, that much you have to do. Okay. I won't teach you again that. If you don't understand, then you can ask me. Okay, fine. Now accordingly, this thing will remain same. Everything it will calculate on its own. You don't have to do. The moment you add here, no, this will change. This also will change automatically. This also will change automatically. Okay. Only the thing is number of member will be 3. So 1, 2, 3. Diameter is a 16 diameter bar. And how many bars are there? 8 bars are there. And cutting length, Excel sheet will calculate everything. This thing plus this will give you the cutting length. Then this will be divided by 1000. This will be total cutting length of in meter multiplied by number of bar into number of member 3. For 3 bars, for 3 such column C8, C12, C25, total cutting length I require 372.24. And since it's a 16 diameter bar, I'm putting the weight in 16 diameter. 372.24 multiplied by 1.58, you'll get the answer. And how you get this answer? Again, same. Development length, this how you find 330. How you find 330? Very simple. Depth of the footing, that is 400 minus bottom cover minus 10. Minus 10, if you get 330. And 470, how you got? Development length minus 330. If I do, I'll get the answer. So what will change? No, in development length, what will change? See here the diameter was how much? Here also it was 16 diameter, no problem. Here also it is 16 diameter. So it is 470, 330. Here also it will be 470, 330. Whereas if the diameter changes, for example, I'll take one case here. Okay, I'll take one case where the diameter is different. Yeah, for example, see here, this one. Here the diameter is 12. So the moment the diameter is 12, here you see it has come to 170 and 430. Why? Because this diameter depends on the development length, 50 into diameter of the bar. So when you take, if you want, I'll do it here. Okay, plus, yeah, we can do it here. So how did you get this 430? You're getting my point, no? So 430 will be how much? Overall depth, that is 500 minus bottom cover is 50 minus 10 minus 10. So I got 430, and this 170, how did I get? Development length is 50 into D. D was this much 12 and minus this one. Got now 170. That is why this change. The moment I change this diameter, this will change. Suppose if I make this 16, now it will match to the previous value. See, it will match to the previous value. Got it? So here I'll make it 12. Okay, correct, right? Fine. Got it, no? Yeah. Okay. So where we reached? Yeah, this thing you understood. Then rest all these things is very simple. You can understand. Okay, fine. So once you understand this, next is very simple. Next again, column size is same, 200 by 350. So you know how you got this 262. You know how you got this 112. Okay, you know how it has to be done. Okay, because this is 300 and this column is 200. So 200 minus 40 minus 40 minus 8. If you do, you will get 112. And rest all things you know. This how it came 940 and all. Okay, this remains same. This also you know how it come 104 and not 4. Right? Simple. Next after that, C9, C10 and C11. This three column. Again same thing. What change will happen? Nothing. So 10 diameter, 10 diameter. So this will be 500. Again the answer remains the same. So 1, 2, 3. So 3 I have written, 16 diameter, 8 bar. Again, from where you get all these things, you have to go back to the drawing. You have to check. Okay. C9, C10, C11. So if I come here, C9, C10, 11 is mentioned here. C9, C10 and 11 is mentioned here. So it is a 16 diameter 8 bar, 16 diameter 8 bar. So that is why in the Excel sheet I have done 16 diameter and 8 number of bar. Accordingly, it will calculate on its own. Okay, that's it. What you need to change is you have to come and verify your answer here. That's it. You have to come and verify this answer. Okay, that's it. Okay, so I'll tell you what will happen. I'll tell you one small thing. Okay, let me come here. See what will happen when you copy that no and paste. No, you'll get something in minus here. You get minus. The reason is that this development length 50 what we added. No, this should be 50, and this I'll do it here only. See what I want to convey is suppose if you're doing in that way, if you're copying something, let us say I copied this. Okay, I copied this. I copied this and control C I did, and I'll paste it here. I'll paste here only. Okay, and say control V. So what will happen? You see, every time you do that, you get minus here. The reason for minus is what will happen? This this is 50 into D, no? 50 into D minus this length. So it will take this value. Just come here, delete this portion, and say development length 50. Enter. Now it will be all right. 470, and this will be 330. Rest all things will be same. Getting my point? What happened? So this only that change you have to do. Okay, great. Okay, that you understood, no? How it has to be done. That's it. Okay, fine. Other than that, rest all things you can do on your own. Okay, yeah, fine. I think up to there I finished. Rest you can do, no? There's no problem. After that, I've explained you. C2 next is this one. Yeah, up to here I've explained you. 3 columns are done. This you can do. After that, C20 was a separate column. So I've taken C21 F3 footing. Okay. And input all this value. Accordingly, answer will come. Then again, next combination was C13 and C16. So if you see the Excel sheet, next was C13 and C16 column on F1 footing, F4 footing, and 13 and 16 falls in the same category. If I search for 13 and 16, see 13 and 16 size is also same, reinforcement everything is same. So that is why obviously it will work out. So I've written 2 columns. So here 2 column, the diameter and there's number of bar is written. Cutting length, everything will be calculated. Okay, fine. And this lateral test remains same for all the column. Okay, that is how it is. Next combination is C15, 21 and 22. C15, where is the combination? See, 15, 21 and 22. 15, 21 and 22. Again here, yeah, see, C15, 21, 22. It falls in the same zone. That I mean, same category, 200 by 350, 16 of it. And this is also same. So that is why I put them in one combination. I mean, in one this thing. Just in case if C22 column was something different, then I should have made one more column and row, and I would have written C22 there. Okay, got it? No, say in spite of this also, if you have doubt, you can get back to me. Okay, no problem. After that, which is a combination C2, C3, C6, C7. So 2, 3, 6, 7. So where is that 2, 3, 6, 7? So that combination is here. See, C2, C3, C6, C7. Again, it falls in 200 by 300 size column, 12 of 6. So I've written the same thing in the Excel sheet. So 12 of 6, 12 diameter 6, 4 number, no? 1, 2, 3, 4. So 4 I've written. Got it? And rest all these things, F6 footing. So F6 footing size is this one. 3000 by 3000 by depth is 500. Depth I've written 500. Accordingly, all the value will get changed. Okay. Fine. Cutting length also you'll find. Then this anyhow remains the same. Why this is same? Because see in the drawing, lateral ties is same everywhere. That means whichever column you're taking, your lateral ties is 8 at 200 everywhere. Okay, you people are lucky that you got a drawing. I mean, I made a drawing in that way where I've kept 8 die at 200 same everywhere. But later, once you understand this, later I'll take some complicated drawings where this won't be different, where this won't be same. In that case, you have to apply your mind. So understand this concept. Later we'll take some complicated drawings. Okay, so that is why I kept this same everywhere. I kept it same, even from footing to ground level, then ground to first floor, then first floor to roof. Everywhere I've kept it same. There are drawings where what will happen, you know, there are drawings where from footing to ground level you will have this 200 center to center. I mean, footing to ground you will have 200 center to center. Let us say from first to second, from ground to first floor also it will be 200, whereas from first to roof and from roof to this level, let us say it will be 300. In that case, this Excel sheet won't work out. Then you have to prepare some other Excel sheet according to that drawing. Okay, so that is why I'm not going to that level right now. You understand this concept, and once you gain the knowledge, you can prepare any Excel sheet. Okay, fine. But I've told you how it is. So that is why I always tell prepare your own Excel sheet so that you can get ready for any of the drawing that is given to you. Okay, yeah. For next, C27, 17, 23, 27, 17, 23. So 27, 17, 23. Yeah, 17, 27, 23. Yeah, 17 is here. 17 is here. Yeah, 17, 23, 27. No, where it is. Yeah. See, now what happened? You know, I'll come here. This is this is a bit interesting. So interesting in the sense, we'll come here. I'll select again once again this one. Hmm. So what happened here? See, what is written? C27, C17. I'll write here. C27, then C17, then C23. Okay, three columns. Check whether they are falling in the same zone. So where is my C27? C27 is here. Okay. Where is my C17? C23 is also here. So both are 200 by 200. It has 16 diameter, 6 bar. That is fine. But whereas my C17, C17 is here. But the column size is different. It is 200 by 350 and it has got 16 diameter, 8 bar. Whereas 23 and 27 has 16 diameter, 6 bar. So now what happened? Even though it is falling in the same group, reinforcement are different. So what I'll do, I'll make a separate Excel for C17 and I'll make C23 and 27 separately. So that is why you see here, I made it separately. First I did for C17. You can see I've written C17 on F7 footing and also I've done C23 and 27 F7 footing. Okay, that is how it is. So again, rest all things I've done one here because only one column is there. Accordingly, all the cutting length and all I've got the answer. Once I get that, next what I did, I went here, 23 and 27, two columns are there. So I put 2, I put 16 diameter 6 bar, no, and here I put how much? Here I put 16 diameter 8 bar. The same thing was there in the drawing. So it was 16 dia 8 here, 16 dia 8 and 16 dia 6 here. Accordingly, I've done the Excel sheet. Got it? And then lateral ties remains the same because that is how we have taken it. Okay, lateral ties you don't have to worry. So here it is. Okay, fine. After that, last, which is left out again. So last C4, C18, C28. So C4, C18, C28. So C4, C18, C28. It's here. C4, C18, C4, C18, C22 falls in the same zone. That is 200 by 350, 12 of 6. So no worries. Just put them in same category. And you write 3 columns here. And it is 12 diameter 6 bar I have written. Accordingly, the cutting length, everything I have calculated. See, finding that itself is difficult. Rest, everything Excel will do on its own. You just have to be careful in finding this length and this length. And everything will do on its own. Okay, fine. That's it. But make sure all these things you're checking my values. No, same answer you should get. Okay, do that. Any doubt if you get, you just message me. Okay, I told you what problem you'll get. The problem what you will get is this one. This problem you'll get. This problem. Whenever you copy and paste, no, I think that is gone. Yeah, this problem you'll get. This problem and this problem because since we have taken this development length, no, here If you observe here, this is N521. Okay, so you have to come and click here. Only then it will consider the development length. Otherwise, it won't take it. Okay, so whenever you copy this, come and verify these answers. And if any mistake is there, you just have to come and change only the development length. Because when you copy, no, it will take the next. I'll tell you what I'm trying to tell. Again, quickly, I'll do this. See now, Control C, I'll do. Okay, I'll not get the same answer this time. I'll get a different answer. See what happened here. I'll get minus 330. What is the reason is that? Why did I get minus here every time? If you copy, you'll get minus. The reason is it will take N51. So why it is taking N51 means this is N and 51 is somewhere here. Okay. So what you do, you come, you take it out and you just select this development length. Okay. Finish. So it will be 470 this. And this length also, it will take this one. So 3 into 50 times the diameter of the bar. That is lap length. So again, come here. Your lap length is 50. Okay. Click on that. Now it is correct, no? See earlier how much it was coming? 12310. But now it will come here. You take it out and select this. Finish. 14710. See one column we got 14710. Correct. Again, if you want to verify, say that. 14710. Getting? Because when you copy, no, it won't take this 50. It will take the next cell, which will be different value. So that wherever the development length you have taken, that you have to change. But if in order to avoid all this problem, if you want to avoid this problem, no, don't link it. You just write 50, then you don't have to worry about it. That also you can do. Instead of coming and saying 3 into 50, selecting this 50, don't select this cell, just write 50 only there. So you don't have to worry about this problem. That also you can solve. You solve it. In case any problem you get, you just tell me, I'll tell you how it has to be corrected. Okay. I think everything I'll solve. Last one thing is there. Okay. Last one footing is left out. That is this one. So C4, C18, C28 also. Next, last is C26. So C26, it is here. Where is C26? Okay, C26 one footing is there. So directly I've taken the, okay, it's not there, but I'll put in here itself. Okay, C26, the size will be given. C26, I'm not able to see that. Anyhow, when I give C26, what I've taken. Yeah, C26 on F9 footing. The size of the column is 200 by 500. And this is a reinforcement given, 16 of 6. No problem. We'll do one thing. I'll just copy this. Okay. And let me go to the AutoCAD. C26 should have been here only. It's not showing. C26. Okay. So C26, it is 16 dia 6 bar. So 16 dia 6 bar. Okay. And what is the size of the column? Size of the column is 200 by 500. So 200 by 500. Okay, anyhow, I'll make one separate. I'll make this only as C26 and I'll send you the drawing. Okay. Because sometime I can make this as C26. Okay. And what is the size of the column? It is 200 by 500. I'll write here. 200 by 500. Okay. Yeah. Okay. 200 by 500. And what is the dimension? What is the column? It is a 16 diameter 6 bar. No, 16 diameter 6 bar. Just I'll copy this part. This entire part I'll copy in this way. Okay. This part I'll copy. Control C and I'll paste it here. Okay. Everything is sorted. Yeah. From here. Okay. All things didn't get selected. No problem. I'll do it and I'll update it. Okay. When I send you this drawing, no, I'll update and send it. No problem. Only this thing I'll copy now for time being. Control C. This will be Control V. And this anyhow it remains same. Got it, no? Rest things, everything is same. I'll just make a changes here. And while I update the drawing, I'll give you the same drawing. Okay. Wherever this column we haven't utilized, that is a floating column, that I'll explain you later. Now you understand up to here how it is to be done. Okay, great. So in this way, all the Excel sheet you have to finish, and that's how it is. Finally, once everything is done, we need to calculate the rebar individually. For that, what I'll do it here only. 8 mm, no, I'll write here. So this one plus, wait, this one plus, yeah, 8 mm plus, this one plus, okay, plus, this one plus, 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 okay, plus, plus. Instead of that, we could have even made use of this auto sum option. Next time I'll do that. Plus, plus, this will take long time because all your lateral ties are falling in 8 mm zone only. Okay, but no issues, we'll do that. Okay, then you do this one, then this one. That's it. Enter. So total 714 kg of steel is required. That is a 8 mm steel is required. Okay, make it at center. Else we could have done the auto sum only. Let me try with auto sum. Wait. It's not coming. Auto sum, it won't work out. Okay, we can make it work out. What we can do is I'll take out and then I'll go in this way. It should work out. Okay. 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 Till here it works out. How much it is? 714 we got up to there, no? Last value it is not working out. Okay. This one value we need to add 8.21 and 24. This also should fall under this only. Okay, it will take some time. Anyhow, we'll do one thing. I'll do one thing. I'll add this in the next lecture. In the next lecture, I'll calculate all these things and keep, and then I'll explain it. Else it will take long time for me to do it. Okay. So up to here, you finish all your Excel sheets, prepare everything. The answer should be correct everywhere. Okay. So this should be 112. Okay. This mistake, whatever we have done, it is 112. You make it correct. Rest all things I made it correct. Okay, fine. Whatever this answer you are getting, no, this side, the breadth side, that should be here. Okay, that's how it is. The column, try to do it. It's very simple column. Okay, you may feel it bit difficult, but it's very simple. You just have to understand the logic and keep on adding. That's it. Okay, and every one floor you have to add a lap length. We'll do the same thing. I'll give this answer in the next lecture. I'll calculate and keep it, and then I'll do that. Okay, otherwise it will take long time now. So practice up to here. Finish your Excel sheets. We'll see you back in the next lecture. Thank you. Hello, my dear students. In this lecture, I'll show you all the column reinforcement that is required. Just note down the values one by one so that you can verify. Okay. For C1 column, in the main steel, you require 196 kg. For this lateral test, you require 24.135 kg. And for this link, you require 8.216 kg. So total, you require 228 kg of steel in this C1 column. Okay. Now come to C8, C12, and C25 column. Main steel, you require 588 kg of steel, that is 16 dia. Okay. Then you for the lateral ties, you require 72.404 kg. And for this, you require 24.64 kg. And if you add everything, if you add this and the main steel, your answer should be 685 kg of steel should come. Okay, fine. Next, C9, C10 and C11 column. Okay, so you require 584 kg in the main steel. You require 72 kg for the lateral ties. You require 24 kg for this. And if you add everything, it should come out to be 681.399 kg. For C20 column, you should get 146 kg of your main steel. 24.135 is your lateral ties, this one. And this link, you should get 8.21 kg. So total, you should get 178 kg when you add everything. Okay. So try to remember this. I mean, try to verify. For C13 and C16 column, you should require 389 kg of main steel, 48.269 kg of this of lateral ties, this one, and this link will be 16.432 kg. So overall, you should get 454 kg of steel. Okay, 454 kg. For C15, 21 and 22, you require 580 kg of main steel. You require 72.404 kg of lateral ties. You should require 24.64 kg of this lateral ties, that is hook. And total, it should be 677 kg put together. Okay, if I add all three, it should be 677 kg. Okay, so see, if you get a value very close to this, even if you get 670 also, it's okay. 7 kg and all, it doesn't matter. Okay, fine. Next, for C2, C3, C6 and C7, you should get 311 kg main steel. You should get 86.268 as your lateral ties. And for the link, it should be 32.864. Total, you should get 430 kg of steel. Okay, now coming to the C17 column, 196 is your main steel, 24 is your lateral ties, 8.216 is your links. So total, you should get 228 kg of steel is required. Then again, for C23 and 27, you should get 294 kg main steel, 48.269 is your lateral ties, and 16.432 is your links. So total, you should get 358 kg. Yeah. So total, you should get 358 kg. Next, coming for C4, 18 and C28, you should get 235 kg of your main steel, 72 kg of your lateral ties, this one, and for link, it is 24. So if I add everything, it should come out to be 332 kg of steel is required. Come to C26 column. Okay, so you should require 124 kg of main steel. You require 31 kg of lateral ties. You require 8.216 kg of links. And if you add everything, it should be 164 kg of steel is required. And now if I add everything, like 8 mm, it will be 773 kg. 10 mm we don't have. 12 kg steel will be 564 kg. Sorry, 12 mm steel. 16 mm steel, we require 3099. We don't have 20, 25 and 32. And if I add everything, that is 773 plus 546 plus 3099, I've added the same thing, all these things. So I'm going to get, wait, this I'll take it out. Yeah. So I'll get 4419 kg of steel is required. But again, you can add 5% of wastage to that. So I'll multiply this value by 1.05. That is 5% of wastage. I will add I'll multiply 1.05, which will take care of 5%. So it will come out to be 464 kg of steel is required, including the wastage. Okay. If you don't want to add the wastage, you can take it out. So try to do the calculation. You should get an answer very close to this. Even if you get 4500 kg also, I don't have problem. And if you get around 4700 kg also, it's okay. Doesn't matter. So this should be the range for the answer. Okay. Doesn't matter. Even if you get 4550 or 4600 also, it's okay. But if you do in this way, that is fine for us. Almost 4.5 tons of steel is required in the G+2 residential building column. So I hope you enjoyed my lecture up to here. Try to verify your answers. I've shown you everything. Okay. And in case if you have any doubts, you can always get back to me. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, we will see how the cutting length or how the BBS for a stirrup has to be done, right? So what I'm practically trying to tell is if you see previously we had done the stirrup or let us say lateral test only for the column, which is something in this shape, isn't it? Now, for example, if tomorrow if you encounter a shape something like this, you can see a kind of a triangle here. So this is how the shape is. How do you find the cutting length of this? So that is what we are concentrating here. Okay. So I just showed you a practical image of that. You can see this particular part. If not, you can see something here. See, if you get a shape something like this, it's a triangular stirrup, what we call. How do you find the cutting length of this? This is what we are trying to find. Okay, great. So something like this. Practically, we give such time. See, if you remember, this is the main reinforcement. I mean, this is a main ring what we had, which you can find easily, isn't it? This you can find easily. Sometime what will happen, you'll have a, and also I did even for the link also. This was a link. So link also, you know how it has to be found. I mean, yeah. So this is a link. This also we understood how it has to be found. Now we are just trying to find on this particular thing. This particular part we are interested in, that if it is something like this, how you will find the cutting length of this. So we'll try to do that. Okay, great. So for that we have certain formulas. If you just remember that, it is well and good. Okay, fine. So I've drawn the same shape here. Let us consider I'm taking a column. So let us consider the size of my column is, uh, I'll go with 500 is the breadth of my column, and I'll consider, okay, I'll go with this, wait, I'll take this as 300, and I'll go, the depth of my column is, let us say, 500. Okay, you can take anything, but we'll start with this. Procedure remains the same, right? So after that, what we are supposed to do, first we need to find this length. First, I want to find this particular length. Okay, if I find this length, it's very simple. Then I want to find the length from here to here. If I want to find the length from here to here, the best idea what I can do is I need half distance from here, from this center. Okay, from the center of this ring, center of this bar, to this center. I want to find the length. Okay, I want to find from this part to this part. Okay, where it is, this part to this part, and this I'll do in this way. So if I want to find this length, if I want to find this length, okay, I want this height, and if I this height if I get, I can easily find out the length from here to here. Okay, you getting my point? So anyhow, I'll tell you all those things how it has to be done. So first I'll write here one by one. First I'll start with cutting length. So if I want to find the cutting length, this is a formula. Formula is B dash. Now the naming I have given, I'll explain you what is B dash and all. You can just note it down. B dash plus 2 times the C plus 24 into D. 24 into D. Okay, this is the formula what you're supposed to remember. 24 into D. So in this B dash will be this length. This will be my B dash. I'll consider this hypotenuse or this inclined as C. This is also C. So 1C here and 1C here. That is why in the formula it is 2C. This I'm going to consider B dash. So it is B dash. And then 24 into D is the hook length that we already know. So if I add everything, I'll get the cutting length of this. Now we don't know what is B dash. We don't know what is C. So that I'll find another formula. I'll put another thing here. I'll say how to find it. So B dash. So B dash will be the breadth of your column. Okay, the B dash will be the breadth of your column minus 2 sides the cover. You're getting my point? 2 sides the cover. I'll do it in this way. Minus 2 sides the cover minus half diameter from of the stirrup from both the side, or you can take 1 diameter. What I'm trying to tell. So we'll do that. After that, okay, I'll tell you one by one, but first I'll finish the formula. You also note down the same formula. Okay, yeah. So B is done. Next, I want to find the C. Next is I want to find C. But before finding C, let me find what is L dash. Okay, I'll find what is L dash. What is L dash? We found B dash, isn't it? So this is my B dash. This is my B dash. So if this is my L, I want to find L dash also. Okay, I'll find L dash also in this way. Okay, so what is, see, I'll consider this as L. I'll consider this column to column outer is L dash. Then from this center of the bar to this center of the bar, I'll consider this as L dash. Very simple. Okay, that's how I have planned it. Fine. Same thing, I'll write the formula for that also. So L dash will be again L minus 2 sides the cover two sides the cover, close the bracket. Yeah. And minus 1 time the diameter of the bar, or d by 2, d by 2. It's one and the same. I'll write d. Finish? Yeah. After that, I want to find one more thing. I want to find b. So what is b? B is nothing but this particular length. So if I want the distance from this center to this center. I want a distance from this center to this center. Okay. This distance I need. Okay. I want distance from this center to this center. Like this horizontal length I want. This horizontal length I want. How we are going to find this horizontal length? So for that, whatever b I have taken here, this is b dash, isn't it? So my b dash should be from here to here. So this is my b dash. Okay. Actually, this bar should have come here, but no problem. I'll show it here only. So this will be my b dash. So this will be my b dash. Okay. Now my concern is I want the center of this. From this center to this distance I want. Whatever b dash I got, if I divide it by 2, I'll get half of this. Very simple. So you can take next if I want, and I'll give the name as b here. You can give any name. Okay. But I'm giving a name b for that. Okay. I'll write b here. I'll give a small b. Okay. Small b will be, you can directly write b dash by 2, or even you can write the same formula, that is b minus 2 into cover, close the bracket, but note down the formula, that's it. Okay. Minus 1 time the d, minus small d, and whatever answer you get, no, this has to be divided by 2. So this is one way of understanding. If you don't want to apply this formula, you can even write b is equal to b dash by 2. That's it. You can write b is equal to b dash by 2. That also can be done. Okay, it's one and the same. No, whatever I've written it here, same I've written it here. Only the thing is divided by 2 I've written it in this way. Now I'll come to find the C. So this I want to find. This C I want to find. This length. This inclined length I want to find. So if I want to find this inclined length, this is not easy. It's a kind of a hypotenuse. So you just apply the Pythagoras theorem. This length plus this. Okay. This square plus this square will give me this particular length. Simple. So I'll do the same thing now. If you want, I'll explain here. I want to find this particular length from here to here. This length I want to find. So for that, what I'm going to do, if I know this I want to find. So to find this, I should know from here to here what is the length. And from here to here, I want to find the length. Simple. This much you understood. So if I add this square plus this square is going to give me this length. And this length I'm going to name it as C. Very simple. You can name anything. You can even name it as Z also. I'm just naming it as C. Okay. And I'm this length I'm naming it as B. This will be B for me. B. Okay. Small b. Small b. And this I'm going to name it as L dash. This I'm going to name it as L dash. Now we are able to understand. So this will be L dash. So now you tell me, if you want to find this, what is the simple formula you will apply? C is equal to exactly cube root of, square root of, you write here. Yeah. Okay. C is equal to square root SQRT. Okay. Then open the bracket 2 times. First you can write anything. You can write this is L dash now. So it will be L dash. Where is my L dash? Yeah. L dash square. Okay. This is square, isn't it? I'll write in this L dash square plus another one is B square. Okay. Small b square. And you close the bracket, finish. Your answer will be ready. This much you understood. So this much formula you're supposed to understand. So try to understand this. If you understand this, your bar bending schedule is finished for this particular type of bar. So that's it. We'll do. Just note down all these things. We'll do the calculation for this now. Okay. So now quickly tell me what is the size of the column and all. We'll quickly do those things. Okay. So what I can do is I'll take a screenshot of this and let me keep it here. Finish. I'll keep it here, and rest everything I'll take out. Okay. So this will be my formula now. Okay. Now just apply this formula wherever you want. Already I've applied and kept. All these things I've done and kept. But we can take one manual calculation and we can do it. Okay, fine. So what will be the manual calculation? You decide. We'll match both the manual and the Excel sheet answers. Okay, fine. So let me take one column whose size is, uh, 200 is my breadth and 500 is my depth. And let the diameter die of stirrup. Okay, let the die of stirrup be 8 mm. That's it. This is the input what we require. Cover, since we are we are doing it for the column only, because this kind of bar stirrup will come in column. In beam, typically you don't encounter such bar. For column, the cover is 40 mm. So this is the input what I have. I want to find the cutting length for this. Very simple. We'll start with this. First we'll start with which one? B dash. First we'll try to find with the B dash. We'll change the color. I'll write here B dash. So B dash. So B dash will be what? B dash will be, what is the breadth of your column? It is 200. So 200 minus two sides the cover. So on the left side, I'll take out 40 mm cover. So this is my 40 mm cover on this side. I'll take it out. This one. Okay. And this also 40 mm cover. From both the side, 40 mm cover will be gone. So minus 40, minus 40, minus 40, minus 40. Minus always will go to the center, isn't it? So half the diameter of the stirrup. This is a stirrup, okay? Half from here, half from here. You're supposed to do that, okay? So I think diameter is 8. So 8 by 2, we can directly say minus D. Finish. So this is a manual calculation. Just do it and tell me what answer you're getting. So it will be 200 minus 80 and minus 8. 112 mm. 112 mm. Fine. So this B dash we got. So this is that 112. I'll write it here also. This will be 112 for us. This straight length we got. Now, once we got B dash, we'll find L dash now, isn't it? So how you'll find L dash? Very simple again. L dash will be, what is a L means length. We'll take 500 minus 40, and minus 8 mm. Again, you tell me what answer you're going to get. So 500 minus 80 minus 8. So 412 mm. Fine. So this one, okay. This will be my 412. This will be my 412. Okay, done. Fine. So this is 112. This is 412. Which is this 412? This 412 is from this center. Okay, from this center to this center, center of this part. Okay, this is 412. Got it? No? What we did? This 500 minus one cover from here, minus one cover from here, half diameter from here, half diameter from here. We have taken it out. So it comes out to the center. This center to this center we have brought it. Okay, great. So this is done. B dash L dash is done. Next, what we are supposed to find? Next, we want B. What we want? We want B. B means we want this distance now. From this center to this center, I want. How you will find from this center to this center? This is already known. This is 412 we got. Now I want this center to this center. It's very simple. We know what is 112. What is 112? 112 is from this center to this center. If I divide 112, I'll get from this center to this center. Agree with me? Very simple will do. So what I'll do, I can directly take this answer and write. I can directly say B is equal to, small b is equal to, what is that, 112 divided by 2. You do it. You will get 56 mm. So it will be 56 mm. Okay. So this is B. Okay. So this is B. This is B, which is equal to 56 mm. So if you don't want to follow this, you can even apply the same formula. Go with the B formula, that is B minus 2 times the cover minus D divided by 2 also you do. You get the same answer. So I'll not do it again. Finish. So we got everything. Now if I want to find the C, I have to take square root of L square plus B square. If I do this, I'll get this vertical, this particular length I'll get. That means if I want to find this now, from here to here, this I want to find. No, what I'll do, simply apply the Pythagoras theorem. 56 square plus 412 square, whatever answer you get, that answer, if you put under root to that, this will be that answer. Okay. So now what I'll do, I'll write C. So now C will be square root of SQRT, square root of which one? 56 square. Okay. 56 square plus which one? Another is 412, no? Yeah, 412 square. Finish. Do it manually. I mean, do it on the calculator. Write square root of under root of 56 square plus 412 square. Okay. Okay. So what I can do is, yeah, I'll do it manually only, but it's not coming here. Yeah. So when you apply the formula, square root of L dash square, L dash is our 412 square plus b square. Okay, that is 56 square. You'll get 415.78 mm. So you got the C length. So C length we have got this capital B dash, and this is 24 times the diameter of the bar. So what should be a cutting length? You just tell me. So the cutting length will be, what is B dash? B dash is, it's written here. Okay, 112 plus 2 times the C. So 2 into C. What is C? C we got 415 mm. Okay. And plus 24 into diameter of the bar, which is 8 mm. So try to do this calculation and tell me what is the answer you're getting. So 112 plus 415 plus 415. Okay. And plus 24 into 8. So this is 1134 mm. So this is a cutting length of my stirrup. You're getting my point? Now, same thing, we are going to get it here. I'll delete everything. Tell me what is the cutting length, 1134, and see how much we got here, 1135 manually. I mean, on the Excel sheet. So I prepared Excel sheet in this way. Okay. And whatever answer we got, the same answer you can see it here. For example, column was my 500. I'll bring that back. Okay. My column was which one? 500 by 200. So length I've done an input of 500 and breadth is 200. Cover was 40 mm, and then dia of the bar is 8 mm. Okay, fine. So B dash, how much we got? So this B dash, it's written here, B dash 112. We have 112 here manually. L dash, how much we got? 412. So we have 412 here. What is the small b we got? Small b 56. Here also we have 56. See how much we got? 415.78. Same thing we got here, 415.78. So we got A, we got B dash, B and C. And then the total cutting length manually I got 1134 mm. And on the Excel sheet I got 1135.577 mm. Got it, no? So in this way you can prepare your triangular stirrup cutting length, or you can follow this pattern. And in the drawing, if you get such kind of stirrup, just apply the formula, you'll get the cutting length. So this is a cutting length what you get. And then you have to tell your bar bender. Okay, you have to tell the bar bender you have to cut a bar of 1135, or let us say 1136 mm. Out of that, out of this bar, I'll tell you how much it has to be in this way. Okay, this separation has to be there. So you have to tell the bar bender that out of that, this will be your how much? 415, no? This is 415. This also will be 415. Your inclined portion, your straight portion is your capital B. So capital B should be how much? 412. This it is 412. This is capital B. Okay. In the Excel sheet, it has to be capital B. Sorry, not 412. It is 112. This is not B dash. Make it as capital B dash. Yeah, now it is correct. So sorry. This is 112. 112, and this hook you are going to provide, isn't it? So hook, you tell him that it has to be 24 into D. So 24 into D, he is going to keep that. Okay, that is 12D on this side, 12D on this side. So 12 into 8 is I think 96. 12 into 8 is how much? Yeah, 96. So this will be 96 mm. This part it is 96, and this part it is 96. So if you tell this much, the bar bender will prepare a stirrup something like this. Got it, no? So you have to tell this is 112 mm. Keep this as 415. Keep this as 415. This should be 96 mm. This should be 96 mm. Is going to bend it in this direction. You'll get. Now again, if you ask me what about the bend detection, no. bend deduction is not required because the formula is directly taken from the code book. Just in case if you don't want to take the formula from the code book, in that case, or let us say if your company people follow that they have to do the bend deduction, then you do the bend deduction here accordingly. Wherever it has got, same bend deduction you can do. Okay. Yeah. But bend deduction is not required here. So you just follow whatever I've taught you. And with this, you'll get the cutting length and the answer will be correct. You don't have to worry again. Okay. Fine. So I hope you have enjoyed my lecture up to here. In this lecture, I explained you how to find the cutting length of the triangular stirrup. Just practice it. And this is a formula what you want. So I'll quickly tell you, cutting length formula is this one. This B dash is this point. This is B dash from here to here. This center to this center is B dash. Okay. And then this is L dash. From this center to this center is L dash. And after that, we would be requiring B. So this will be B from here to here. So if you get all these things, and if you square root of this square plus this square will give you the inclined length, and this will be your C. So the moment you get C, we have two inclined, one C here, another C here. By here itself, you'll understand the formula. One C here, one C here, and this is my B dash. So obviously your formula should be B dash plus 2 times the C plus hook length is 2040. That is the formula. So if you understand the concept like this, no, you can prepare your own formula. Now you understood the concept. Else, if you keep on behiting like B dash plus 2C plus 2040 in tomorrow, or let us say in some other company, or maybe if you refer some other lecture, instead of B dash, those people might be using here D dash. Those people might be using here D dash. So in that case, you may feel difficulty. Like sir thought is B dash, but this guy has taken C dash. So I have taken this inclined length as my C. Somebody people may take this as F, right? But if you understand the formula, it's very simple. In that case, his what is that? Formula itself will change. In that case, he'll put a formula of cutting length will be D dash plus it will be 2 times the F and plus it will be 24 into D. So again, you'll get confused in that case. Sir taught us this formula like you behind like B dash plus 2C plus 24D. Here it is D dash plus 2F. So that is why always try to understand how this formula is coming, and rest you can do it on your own. Yeah. So I hope you understood the concept. So after this, if you get any stirrup something like this, you can easily find the cutting length, and finding the number of bars and all remains same. Number of bar is total height divided by the spacing, that all remains the same. Only the thing is you wanted to find the cutting length of this bar. This is how it is to be found. Okay. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. Once we have seen the triangular one, next we'll try to see how to find the cutting length or how to make a BBS for the diamond ring. So practically you may encounter such type of rings also. You can see the ring here, right? So the ring has come in this way. Then it has gone here. Then it has gone here. Then it has gone here, right? Along with that, they are given two hooks. So this will be common for all the stirrup, right? Agree with me? So how do you find the same thing? I've drawn it here. How you are supposed to find the cutting length of this? Again, it's very simple. So if you just observe here, we just have to find this particular distance from here to here. If I find this distance, then this distance, and this distance, everything will be same, right? This much you can understand. I'll name this as C. This inclined distance, whatever I'm getting, I'll name it as C, or I can name it as D or whatever. I'll name it as C. Finish. Can you tell me the formula? How many C I am supposed to add? 1C, 2C, 3, and 4. That means 4 times I need to add the C. And this is your hook. And hook directly we know it's a 24 times the diameter of the bar. Finish. Your cutting length will be directly, I'll write it here. So your cutting length CL. Your cutting length will be 4 times the C, right? Plus 24 into D. 24 into D. Finish. Your cutting length is ready. Where D is the diameter of the bar. Now, how do you find the C? So that is a big question. How this C has to be found? So for that, whatever I've drawn now, that is a stirrup. So usually this will be a column, isn't it? So usually this will be a column. So how do you find this length? It's very simple. We'll be knowing this length, isn't it? This column dimension will be knowing. This is the breadth of the column and this is the depth of my column. I need to find the C distance. To find the C distance, I should find the center of this to this. And if I find the center of this to this, obviously I'm going to get the answer, right? Again, it's the same, exactly. Again, it's going to be same Pythagoras theorem. So I want to find this and this, that's it. From this center to this center and this center to this center. So how you will find this from this center to this center and this center to this center? It's again very simple. This overall length we know. If it is the breadth of the column, from here I'll deduct one cover. From here I'll deduct another cover. Half the diameter of the bar from here, half the diameter from here. I'm going to get the distance from this center to this center. If I do that, I'll get the distance from this center to this center. And if I do half of this, obviously I'll get this answer. This anyone can understand. In the same way, if I want to find this distance, if I want to find this distance, that is from this center of the stirrup to this center of the stirrup, how we will do that? It is also again simple. Overall depth, this depth minus one cover from here, minus one cover from here, minus half the diameter of the stirrup from here, minus half the diameter of the stirrup from here. Whatever answer I'll get it from the center of the stirrup to the center of the stirrup. But I want from here to here. So whatever answer I get from here, if I divide it by 2, will I not get that answer from this center to this center? Obviously. So when I know this length and when I know this length can be easily found with help of a Pythagoras theorem. That is what we are supposed to do now. I hope this much understanding is clear for you people. So that's it. So with this understanding, we'll just try to input the values and I'll explain you all those things, how it has to be done. Got it now? Very simple. The formula is clear. If you want to see where exactly the formula is given, again, you have to refer IS 2502. And if you come here, the shape is already drawn here. This is a kind of the diamond shape. What is the formula? 4 times the C plus 24 into D, where C is this one. Okay, this is C for them. That is this inclined one. Okay, and 24 into this is 24 into D. Okay, very simple. Got it? So that's it. Finish. We'll try to find the cutting length. First, I'll find the this thing. What is that? Uh, Formula. I'll apply one by one. So let me bring the formula here. So cutting length is this much. And how do you find the C? So C can be found with the help of this square root formula, that is SQRT. How much it will be? SQRT, it will be L square, SQRT L square, okay, L square plus, which is the other one? The other one I'll consider to be B. Okay. You can give any name, okay? Just understand the concept. That's it. Finish. Fine. Now what is L? So L will be capital L. That is overall length of the column minus two sides the cover, 2 into cover. Okay. Minus 2 into cover. Minus 2 into cover. And then minus the diameter of the bar. Minus D. Diameter of the bar means diameter of the stirrup. Always remember this. Okay. Yeah. And whatever answer you get here, whatever answer you get, this has to be divided by 2. Only then I'll get the small l. Okay. Fine. Next, after that, how to find small b? The small b also can be found easily. Small b will be equal to, again, this one. Okay. Capital B minus 2 times the cover. Okay. Close the bracket here. Open the bracket here. Minus again D. Exactly. Then again, close the bracket. You divide it by 2. That's it. Very simple. This much you understood. So if you understand this much, finish. So I'll write the formula. I'll take a screenshot and keep it. Finish. 106 into 256. Yeah. So it should be no this answer 277.0076 0776. What I did, this is a formula, okay? So whenever you do in the Excel, no, use this formula equal to plus square root of open the bracket, 2 times open the bracket, input the value, close the bracket, and use this symbol and square plus open the bracket, put the value, close the bracket, and to the power of 2 and close the bracket. So I'm getting 277. Finish. So this answer is 277. This inclined answer is 277 for me. I'll just come here. If you want, I'll write 277. I'll write enough. Finish. So you got it, no? Inclined length you got. So this inclined length you got. This is 277. This also will be 277. This also will be 277. This also will be 277. We add all the 277 plus this is 24 into D. So the cutting length will be the same thing. Okay. It will be 4 into C, isn't it? Formula is 4 into C. So in our case, C is 277. Close the bracket plus 24. 24 into D. Diameter of the bar is 8. You just do that. 277 into 4 is 1108 plus 24 into 8, 192, and add it 192 plus 1108. So this is 1300 mm. So this is the cutting length of your bar. That's it. Finish. Can you do it? Now coming to the number of bar, it's very simple. Number of bar and all you can do. Whatever is the length of your column, you divide by the spacing of this, you'll get the number of bar. That thing and all you can do on your own. Okay. I think that much knowledge you have now. Only the thing is how you want to find the cutting length. That was important. I thought you here. If you want, we'll prepare the Excel sheet also. Excel sheet, you know how it has to be prepared. Anyhow, I'll explain. So first we'll input the length here, and then the breadth has to be inputted here. You do the similar Excel, then you cover you right here, and then dia of the stirrup. Okay, finish. So once you do this, after that, what all things is required? We want to find L, isn't it? We want to find L, and we want to find B, right? So your column is how much? Column we took it as the length of the column was 600, and the breadth we took it as 300. Cover for the column will be usually 40. Dia of the bar usually stirrup will be 8 mm. Fine. This much is done. Next we'll find L1, L part. Okay. So how do you find the L part? So L part will be always plus open the bracket. This 600 minus cover 2 times and minus half the dia. Whatever answer you get, no, this has to be divided by 2. Finish. The answer is ready. 256. We got manually. Same thing I got. Similarly, come write small b, or you can make it as a capital B also. Doesn't capital B I've given it here. I'll make this a small b, and this I'll make small l, not capital L. Make it a small l. Okay. So how you'll do this again? Plus open the bracket 300 minus 40 and minus 8 and close the bracket and you divide it by 2. Finish. Your answer is ready. To 106. We also got 106. Now next is what? You have to find the cutting length. No, just add. Next is you have to find the this thing. What is that? Pythagoras. For that, I'll give the name as C. Okay. And how we'll put the formula? Plus SQRT square root 2 times open bracket. Okay. First click on this. Close the bracket. Click on the shift button in your keyboard. So and click on this. So it will be square. Plus again open the bracket. Click on this. Close the bracket, use this symbol. It is on keyboard number 6. Over that, you'll find this symbol and say 2. Okay. And now you close the bracket. Finish. Done. 277. Manually, we got 277. Here also, I got 270. Finish, no? Now, how you'll find the cutting length? If you want that, use such this thing. So, write cutting length. Cutting length. Cutting length formula will be very simple always. Nothing. Just click on this. What you'll do? 4 into 4 multiply by this answer plus open the bracket 24 you write into diameter of the bar which is 8 mm. Close the bracket. It should match. Finish now. 1300 we got. Manually also you got the same thing. Excel sheet also finished. My Excel sheet is ready now. So now if you give me any problem, I can do any problem which is given to me. Just come and input the values. Rest all things I have taught you how it has to be done. Okay. Finish. Here. Now, if I want to change the column, let us change. Let us have a column whose size is 500 and whose breadth is 250. Finish. Answer is ready. This will be the cutting length. Let us have a column whose length is 950, whose breadth is, let us say, 450, finish. Your cutting length is ready. Accordingly, your cutting length is ready. Okay. Instead of 10, instead of 8 diameter, let us say they are using a 10 diameter bar, finish. No problem. Answer is ready. Everything is ready now. Finish. Just this cutting length I found. Now you find the number of stirrup, multiply the cutting length, will get the total weight. And with that, you multiply by the weight of the 10 diameter bar, which is 0.613 or 0.62, and the total weight required. Got it, no? So this is how you are supposed to do the calculations, and this is how you are supposed to do the BBS for this kind of stirrup. So you have learned also how it has to be done. Yeah, I'll just keep it here. Chances. Yeah, that's it. So I hope you have enjoyed my lecture up to here. So in this way, if any problem is given in your drawings, okay, just apply the same formula and get it done. Your answer will be ready. Right. So we'll see you back in the next lecture. Thank you. Hello, my dear students. Welcome back to the lecture. So in this lecture, we'll see how to find the cutting length of a circular shape. Okay. Again, it's very simple. It's very simple. Just you should know what is the length and what is the depth. Okay. And then, I mean, of course, that is not required much. You just need the diameter of the rebar. Okay. So I'll tell you, I'll first write the cutting length formula. So if I want to find the cutting length, I'll write it here. We'll start from here. So cutting length, yeah, Length, yeah. Cutting length will be pi. So pi is the formula what we are supposed to apply. So I think pi cannot be written here. So I'll write pi. Okay. Pi means 3.142. Okay. I think, yeah, in my keyboard, I cannot write pi. I don't know how to write pi. So I'll write pi. It's understood that you have to take pi into d dash. Okay. So what is d dash? That I'll explain and close the bracket. That's it. Plus the hook length. Hook is by default 24 times the diameter of the bar. Take it at 24 into d. Finish. Your answer is ready. This will be a cutting length. Now, one question which comes in your mind is about the d dash. What exactly is this d dash? So d dash will be, this d dash will be whatever is the diameter of your whatever is the diameter of the column. Okay, because this is circular column, no? So they will be given a diameter. So whatever diameter they give, minus 2 times the cover. Minus 2 times the cover. Okay, that's it. Finish. Minus 2 times the cover. You do it. And minus half diameter from the left side, half diameter from the right side, or you can directly write minus the diameter of the stirrup. So if you do this, your cutting length will be ready. Okay, fine. So this is how it is. This is how we are supposed to find. So this will be your d dash from this center to this center. This is your d dash. If you find this d dash, how to find the d dash? You will be given the diameter. D is the overall diameter. That is from this outer to this outer, one diameter will be given. Okay, or they will be they will be written a circular column. Circular column. You need to provide whose diameter is 500 mm. So this is how the uh, drawings will be given. Okay, finish. The moment they give 500, that is my diameter of the column. If I want to find the d dash for that, it's very simple. I'll do for that only. So d dash will be how much? So d dash will be 500 minus 2 times the cover. So cover is usually 40 mm no, for the column. So 2 into 40 minus 2 into 40 and minus the diameter. What is the diameter? Let us say I'm using a 8 mm bar. You just do the calculation and tell me what is the answer you're getting. So 500 minus 40 minus 40 minus 8. So it is 412 mm. Finish. So this is 412 mm. Now cutting length will be how much? So cutting length will be, pi. So pi is 3.142. Okay. But the unit of pi is 3.142 multiplied by d dash. So d dash I already found. So if you want, I'll take it in one. Okay. This is d dash is 412. Okay. If you want, close the bracket here. So this is pi into d or pi into d dash. Okay. And plus 24 into diameter of the bar. Okay. What is the diameter of the bar? So diameter of the bar is 8 mm. No, that's it. Finish. You got the cutting length. If I ask you what is the cutting length for this particular diameter, you just have to tell me, sir, 3.142 will multiply it by 412, and whatever answer we get, we'll multiply that 24 into 8. So I'll get 1486.50 mm. That's it. So this is the cutting length of my bar. Whatever bar I have now, this is the cutting length. 1486 bar if I cut. And if I tell the bar bender that this is a diameter we have 500, accordingly is going to make this and is going to keep this as 12D and 12D. Got it? No? That's it. If you want, I think here if it is given, we'll try to see. If yeah. So the same shape, that shape is not given, but this is a formula what we are supposed to follow. Okay. Circular is not seen here. Circular shape. No problem. You just refer whatever I've told and that is correct. Okay, great. That's it. So if you want a small Excel sheet to be prepared, you can do that also. Anyhow, we'll do an Excel sheet, which is very similar to this. There's nothing to do. If you want, I'll write. Okay. So we'll write capital D here. The diameter, we'll input it as 500. And then I want to find the formula, isn't it? So cutting length, I'll write C dot L. So cutting length, this will be formula. So we'll write plus, open the bracket, 3.142, 3.142. We have to multiply this by D dash. For that, I'll write D dash here only. So this is D. And I think, wait. So you just have to plan when you prepare the Excel sheet. So diameter, I'll write it here. And then after that, wait, no, diameter, I'll write it here, 500. Okay, this I'll go for cover. I'll make this as cover. And this is another dia of the bar. That's all right. Yeah, finish. So cover will be 40 mm. Dia view using a 8 mm bar. With this, we can prepare our Excel sheet. So D dash will take directly from here. If you want, you can take D dash also from here. So we'll write D and D dash. You can do in this way also. And D dash will be always 500 minus 40, minus 40, minus 40, and minus this. Yeah, 412. Now you find the cutting length. So cutting length, you can write CL. Cutting length will be always plus, open the bracket, 3.142 multiply by D dash, close the bracket, plus 24 into diameter of the bar. Finish. You should get the same answer. Got it? Say 4148. Now nothing. Just you have to change the value. Tomorrow you may get a column who has a diameter of 650. Finish. The cutting length is ready. Tomorrow you may get a column where the diameter is 300 mm. Accordingly, your answer is ready. Finish. So this is a cutting length. You tell the bar bender, he'll prepare it. Got it? No? So in this way, if you learn to prepare the Excel sheets in this way, that's the best way that you can do. So what I'll do is I'll just take it out. Okay. Yeah. So I hope you have enjoyed my lecture up to here. Try to practice it. Try to understand what you're supposed to do. Rest all things are very simple. So we'll see you back in the next lecture. Thank you.